Okay, for all the people out there who believe that 2012 was the end of the world, and partly due to that is the fact that we're going into a solar maximum, and that the solar maximum is going to be larger than any other before, and we're going to get hit by a super flare, and etc., etc. Well, here's some data since January of 2000 until now, October of 2012, of actual sunspot numbers per month, and then the blue line is the smooth series, and then the red line, of course, is their predicted amount. No, you don't have to trust this, but statistically speaking, the predicted amount is pretty accurate. And knowing what we do know about the cyclical movement between solar minimum and maximum, it's actually not that hard to predict within the coming months and even into a couple years what we're looking at. But from this data, it looks like we're almost already peaking solar maximum, plateauing out, and then possibly moving out of solar maximum, and we're going to start seeing a decrease of sunspots per month. And if that were the case, this is an extremely weak solar maximum. This is probably the weakest solar maximum in the past 200 years, possibly. But what I'm going to show you real quick, this is data, and the source is from NOAA and the Space Weather Prediction Center, but it's only since January 2000. I've collected data from the same sources since 1749. January of 1749. The smooth number of sunspots per month internationally, not just in the U.S. And per month, this gives me over 3,000 observations. So what I can do is I can treat this data purely as a time series. Basically, the number of sunspots per month is a function of time with no other factors involved. And with that, we're going to see if we can predict in the future what we're looking at, and whether or not we're already peaking at solar maximum, or we have to look forward to maybe a continual rise in sunspots per month. So I have here over 3,166 observations of actual data. Now let me show you really quick what that looks like in a graph. Now remember, this is since 1749. And as you can see, just like most people know, the sun is very cyclical, going from a solar maximum to a solar minimum. Minimum being no sunspots, 0, and then a maximum with a lot per month, and this is per month data. And as you can see, it's very cyclical. Now from a statistical standpoint, I would consider this data very seasonal. A seasonality being every 11 years, we're going from a minimum to a maximum. And here we are right here in October of 2013, and we're seeing just under 100 sunspots per month. Now the question is, are we going to continue up, and is this going to be a large solar maximum like past anything we've seen before? We're already starting to decline. Now, being that this is a seasonal model, one of the best things you can do is fit it with a seasonal prediction type of model, and specifically the whole winter seasonal smoothing model could really help you predict that. But first, let's look at what it looks like with the linear best fit in the model. Here's the same model. This line represents basically the basic trend of the data. Now remember, this is since 1749. Now this line since 2000 is actually decreasing. But in an overall longer term trend since the 1750s, we're looking at an upward trend of sunspots. So on average, since 1750, we should be seeing more sunspots per month. Now that's just a linear fit. Now, let's fit it with a whole winter seasonal smoother, which I've already calculated. Okay. This is the whole winter seasonal model here. And as you can see, it's almost exact to the data. Now over here where it's see dips, now that's its prediction. Now let me explain this a little better. So the blue line, which you can barely see because it's being overlapped by the red line, the blue line is the actual data, the actual observations, and the red line is my prediction. And then you have your linear fit. So let's zoom in on this area right here where we're more interested so we can see the data a little better. Okay, here we go. Now this is October right here. And my whole winter smoothing parameter model is predicting this. This is a total of a 5-year prediction. This is 60 observations out of the set data, and that's what a whole winter smoothing parameter is looking at. So we're looking at a decay. We're looking at minimum is pretty much already has been maximized, and we're going to be moving out of it. Let's zoom in even more. Take a look at this data. Okay, here we go. So this is basically since a little prior to 2000. And where the green line ends is the actual end of the data here. Okay, and there's my whole winter smoothing model predicting a decline in sunspots per month. So from this model, you would say that, yeah, we're moving out of solar maximum. Let me list the data so you can take a look at it. So I'm going to list the actual sunspots per month, my prediction over a function of time, and I'll put the date in there for you. Okay. All right. So here's 2012, October of 12 here. Our actual data is 53 sunspots per month, and here's my predicted number. And as we move down, you can see we're starting to decrease. We're getting a little, I'm hoping we get more sunspots so we can get some activity and get some cool images. But it looks like in the coming years, this is by month, just to remind you, now we're declining from 61, 60, 56, 55, 54, 59, 53, 47, getting into the 40s, and the 30s, and then even in the 20s, 24. So it looks like we're moving out of a solar maximum, and the solar maximum was pretty weak. And if you don't trust these models, they're probably the best because of how cyclical the sun is. It gives us reason to predict it quite accurately. And you could always, if you want to see even more, what you could do, I've already actually made this. I'm taking the first difference of the sunspot numbers. Now in the blue is your stationary series. Now the stationary series is easier to predict because it's stationary. But it's not even appropriate for this model because of this model's seasonality. So just to show you again, this is what we're looking at. So the next time somebody says, the solar maximum is going to be larger than anything else before, and we're going to get destroyed by super flares, to be honest, the data is indicating towards we're moving out of solar maximum, and it was pretty weak. And this is just with my experience with statistical software, but the experts would agree. And if you like the source of this data, I'll put a link in the description. And it's actually quite amazing because we have data actually daily. Here's the website. Let's see if this loads real quick. Here's information on sunspot numbers since 1818 here. But if you click on these monthly plot data or the daily plot data, they go from like the mid-1700s. Now there is missing data, of course, that there's been speculation about in the 1600s, the Bronzer minimum and other stuff like that. But treating these numbers purely as a function of time and having more than 3,000 observations to work with is very, very helpful, and it's quite easy to get an accurate prediction months in advance. But tell anybody that they're retarded if they believe in the 2012 hype.